Hello students, welcome to your lesson on box plots. Today we're going to be learning about how to create box plots, but first we're going to talk about some other graphs that you've seen before. Box plots are really just another way to display data, just like you do in circle graphs or pie graphs, stem and leaf plots. This is something that you definitely display your data values in, dot plots, and probably the most common, bar graphs. Data can be displayed in a variety of different ways, and there are so many different pros and cons with the way in which data is displayed. But today we're going to focus on the pros associated with box plots and really dive into that work. So first I want to show you a picture of what a box plot looks like, because in order to create one, first you kind of need to see what it's going to look like at the end. On box plots, you have a box in the center, and then you have two lines headed out, and those lead you to both your minimum and your maximum. When we think about minimums and maximums in everyday life, minimums are going to be our lowest value, which is exactly what they are on a box plot. And our maximum is going to be our highest value. And that's exactly what that represents on a box plot as well. We also have the lower quartile and upper quartile. We have Q1, which is kind of an abbreviated version of saying lower quartile. And then Q3 is our abbreviated version of saying upper quartile. And then we have the median in the center. Y'all are very familiar with this vocab word at this point in time. That is going to be in the middle of the box because it's in the middle of your data set. So we can talk about this more later once we start forming our box plots, but I want to get into the process of how we actually create them. So first, step one. Like we do whenever we're finding mean, median, mode, and range, the first thing I encourage you guys to do is to always order your data from least to greatest. This is the most helpful way to make certain that you truly are finding the correct values when you go back and find all these different measurements. Next, you're going to need to find the middle of your data set, also known as the median. When you find the median, we do this exactly the same way that we normally do when finding data. I think the thing that always spooks people when they're finding the median is when they're left with two values in the center. And when you're left with those two values in the center, you just find the average of those two numbers. And once you find the average of those two numbers, you have truly found the median. Next, we need to find these two measurements that are only found on a box plot, the lower quartile also known as Q1, please put that down, and the upper quartile, also known as Q3. So when finding the lower quartile and the upper quartile, you're basically finding the median of both the lower half of the data and the upper half of the data. So when you have an odd number of values in the data set, you're not going to include the median when you find Q1 and Q3. But if you have an even number of data set or numbers in the data set, the median is in the middle of those two numbers, just kind of like what we mentioned above, and you still don't include the median. So this is really a pretty word-heavy way of saying once you find the median, completely disregard it because you won't be using it. So we know how to find each of our pieces now from our steps, but I learn best from an example, so we're going to walk through an example of how to truly create a box plot. So starting down here, we're given our data set, which is great. We have all of these values. But looking at them, I certainly am not going to start finding my values here yet first, because I need to always order my data from least to greatest. So in ordering my data from least to greatest, I kind of go through my data set and try to find my lowest number, which is looking like that 7, and write that down. Then next comes an 8, but there's not just one 8, it looks like there's 2 more. So I have a total of 3 8s. Then my 9s, 1, 2, 3, 4 9s. Then 2 10s, and a 13. So I have all of these different numbers that compose my data set. One of the things I always like to do, just so that I don't accidentally miss a number and then get every single step of this wrong, I'm going to count my numbers and make sure I have just as many now that I did when I started. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm all good. Now I can start finding my values. And for me, I always like to start with the easiest ones first. Looking at my list, minimum, lower quartile, median, upper quartile, and maximum. Your minimum and your maximum are going to be the easiest ones to find. Minimum is just your lowest number, which in this data set is 7. Your maximum is not the lowest number, it's going to be the highest number, and in this case, it's going to be 13. 2 down, okay? So now what we're gonna do is focus on step 2, which asks us to find the median. So I always find my median by crossing off a lowest value and a highest value until I get to the center. So 1, 2, 1, 2, 1, 2, 1, 2, 1, 1. Boom, my median is 9. Now that you've found your median, you really need to eliminate it because it's truly in the center of your data. So I'm going to draw a line directly through my median. This is separating my data into a lower half and an upper half. Because the median is our middle point, half the data is below, half the data is above. So now we're going to find really a second set of medians, and we're going to do this through our lower quartile and our upper quartile. So I'm going to find my lower quartile first. So I'm going to focus on my lower half of data. And what I'm going to do is cross through and find the median again. To find the median, you get rid of your lowest value and then your highest value. Lowest, highest, boom, 8 is the only number I'm left with. And that is in the middle of my lower half of my data. So my lower quartile, or my Q1, is just 8. Then I'm going to go to my upper half and do the same exact thing. So I need to find out what's in the middle of my upper half of data. So I'm going to get rid of my 9, then the 13, another 9, 10, boom. 10 is going to be my upper quartile. These are all the key values that are going to play a big role when I actually make my box plot. So my only issue is I have a blank number line and I need to make sure that these are in very precise locations. So looking at my values, my numbers ranged all the way from 7 to 13. So that's a difference of 6 different spaces, and I have plenty of room on my number line. So I'm just going to start at 5 here. You could start at 7. That's totally fine. I just like to start a little bit under so there's room on either side. So 5, 6, 7. Boom. Okay. Number line handled. So now what I need to do is start plotting my values. And I'm going to plot them in the same order I found them. I'm first going to start with my minimum and maximum at 7 and 13. These are always nice to plot because they're just circles, handled, done. Now I'm going to go in, I'll kind of check these off as I go, and I'm going to plot my median, which is in the middle. The median was represented, if you look at the top, by that center line in the box. So I'm just going to draw a vertical line on the number 9 because that's my median. Next, I'm going to plot the lines that compose my lower quartile and my upper quartile. My lower quartile was at 8, so I'm going to draw a nice long line on that one too. And then my upper quartile is at 10, handled. So I have all of my items marked, but at this point, I know I'm creating a box plot and I don't see a box anywhere. So what I'm going to do is create my box. These 3 lines are going to help me do that. I'm just going to draw a line, connecting them. Perfect. Now I have my box. My median is still in the center. This is my lower quartile and my upper quartile, but I have these 2 dots that need to connect to my central box, just like they did in the picture up above. So I'm just going to draw a line from the box to each of those dots. And that is my box plot to represent the data set on example 1. Okay, moving on to example 2. We're going to do one more. So on this one here, we have our data set. Again, it is definitely a no-go to start just crossing off values from either side to find your medians from this, because we need to make sure we order our data from least to greatest first. So I am looking at these values and I see 1 is my smallest number, but it looks like I have 2 of those ones. So I'm going to draw another one. Then looking at this, I have a 2 and then a 3. And then 2 7s. Oh, 3 7s. And a 9. So again, I'm going to count my values and make sure I have just as many on my ordered line than I did in my original data set. So 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. Awesome. Step 1, looking at my list, I'm going to get my minimum and maximum out of there because I know that that is the easiest one for me to find. My lowest number is 1. My highest number is 9. Handled. Now, I need to focus on my lower quartile, median, and my upper quartile. I can't find my lower or upper quartile until I really find my central point. So I'm going to do that here. 1 is gone, 9 is gone, no 1, then no 7, 2, 7, and I'm left with 2 numbers in the center. You do not panic at this point. You just find the middle of those 2 values. And so when I think about 3 and 7, there's 2 ways that I can find out what's in the middle of them. What I could do is I could write out 3 and 7, and then write out all the numbers between them. Like 3, then 4, 5, 6. Well, I may have spaced that a little awkwardly, but we can still find the median again through there. 7, 3, 6, 4, and I'm left with 5. So I know 5 is going to be my middle number between them. Another option, this is the way I prefer because I feel like it's a lot easier when you start dealing with bigger numbers. So we're trying to find what's in the middle between 3 and 7. We can really just average the numbers. And when you average something, you add those 2 numbers together and then divide by how many you added. 3 and 7, that's just 2 numbers. So first I'd add them together and then divide by how many I added. 3 plus 7 is 10. I'm going to go and divide that by 2. 10 divided by 2 is 5. We got the same answer both ways. Both methods are effective. Choose a way that works for you, or you can totally just alter it just depending on what your values are. So right here, I've decided my median is 5, and that is going to split my data set in half. So what I'm going to do is draw that line separating my data set into 2 pieces. And that line is getting drawn at 5 because that truly was my median. So now I have a lower half and an upper half of my data. And I'm going to find the medians again. First, I need to find the median of the lower half to find my lower quartile. So looking at this, I'm going to get rid of the 1, get rid of the 3, and now I'm left with 1 and 2. What is in between 1 and 2? I don't know. So I'm going to have to use my method of finding the average of those two numbers. And I find the average by adding them together and then dividing by how many I added. 1 plus 2 is 3. 3 divided by 2 is 1.5. Some of you guys were probably already able to tell me that 1.5 was in the middle between 1 and 2. But if you weren't, that's totally okay. Just use our process of adding them together and then dividing by 2. Next step, we need to find our upper quartile. So I'm going to focus on my upper half of data. Start crossing from either side. And we're left with 7 and 7. That is the best case situation when you're trying to find what's in the middle between two numbers, because those two numbers are exactly the same. What's in the middle between 7 and 7? 7. Now, if you're in this situation and you look at these numbers and you're a little worried because you're like, oh no, what's in the numbers? What's in the middle? They're the same. You can always use the same process. 7 plus 7 gives you 14. Then you have to divide that by 2. What's 14 divided by 2? 7. Boom. Same answer. Okay? So now that we have all of our key players here, we're going to go and plot them on the number line. Now looking at this number line, it's the same exact number line, blank. So we need to fill it in. It looks like my numbers range from 1 all the way to 9. So I'm just going to go and start my number line there at 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. Just finish it out for good measure, 10 and 11. Awesome. So now we need to begin plotting. If you remember from last time, we have our minimum and maximum that we always plot first. So my minimum is going to get a dot at 1. My maximum is going to get a dot at 9. Handled. So now I get to move into my quartiles and my median. So my lower quartile is at 1.5, my median is at 5, and my upper quartile is at 7. So what I'm going to do is plot each of those. My median is going to get a line at 5. My upper quartile gets its line at 7. And then over at 1.5, which is right in the middle between 1 and 2, my lower quartile is going to get its line. So again, no box in sight just yet. So I'm going to create my box. And I create my box by connecting my 3 lines together and drawing a line out to my minimum and maximum. So here I have my box plot. Now, I'm going to throw in one extra piece of information because it is important when you're finding and when you're really graphing with the box plot to find the interquartile range, because it's such a valuable piece of information that only box plots provide. So, and the interquartile range is the difference between Q3 and Q1, okay? Q3 and Q1 are those upper quartiles and the lower quartiles. So when you're finding the difference between those 2 points, you really find out, well, how big is your box? So in this instance, looking at my box, my Q3 has a value of 7. My Q1 has a value of 1.5. So I'm going to subtract those 2 numbers. Now, if you remember, when subtracting whole numbers and decimals, you have to make sure you line all the decimal points up. But on 7, there currently isn't a decimal point there. So I'm going to make sure to add a decimal point and a 0 after it. And then I'm going to subtract 1.5 from that. When I go to subtract 5 from 0, I know I can't do that. So I'm going to borrow from my 7, turn that into a 6, and my 0 becomes a 10. 10 minus 5 is 5. 6 minus 1 is 5. Decimal point comes down. My interquartile range is 5.5. So that's something that you're going to be asked to find when you're asked questions in reference to box plots, so please make sure you remember that your interquartile range is your third quartile minus your first quartile, or your upper quartile minus your lower quartile. I wish that they didn't choose so many different names to represent different features on a box plot, but they did, and so we need to be familiar with all of them so that we're successful no matter who is asking us the question and what set of vocabulary words they prefer. Now, we have our interquartile range, but please remember that there is just normal range. And normal range is always your biggest number minus your smallest number. That will be your maximum minus your minimum. Don't let the fact that we have interquartile range confuse you with regular range. Regular range you just find subtracting your biggest from your smallest value. Okay, so we're back with the first picture of box plots that we ever saw, and I want to add some additional information to this. I didn't want to overwhelm you all at the start by just giving you all this information and not really explaining it too well or not touching on it till the end, but there's one more piece of information that I want to give you that pertain to box plots. We're referencing all of these lower quartiles and upper quartiles, and whenever we talk about quarters in maths, we're talking about a fraction or a percentage of a whole. So when we're talking about a quarter of something, we're talking about 1/4 or 25%. And one of the things that's great about box plots is it really separates your data into 4 different sections. And this section here that goes from the minimum to the start of the lower quartile contains 25% of your data, and this section from your lower quartile to your median contains another 25% of your data. Then the section from your median to your upper quartile contains 25% of your data. And lastly, the section from your third quartile to your maximum contains the other 25% of your data. So in this, we have 4 different sections, each representing 25% of the data points. So questions that you could potentially be asked. What percent of the data is contained between the minimum and the median? So if I want to find out what percent of the data is between the minimum and the median, I have to figure out how many sections that covers. Well, the minimum to get to the median, I have to take 2 of those 25% hops, which is a total of 50%. So in between the minimum and the median, 50% of your data is housed. So another question that you could be asked, what percent of your data is contained between the lower quartile and your maximum? Well, I have to start at my lower quartile and count the number of sections between my lower quartile and my maximum. And I have to make 1, 2, 3, 25% hops. 3 25% equal 75%. So 75% of my data is between the lower quartile and the maximum. We'll practice more on this in the context of a problem, but let's continue on from there. So applying what we know, this is where we're going to have to create a box plot and then answer some questions about it. So starting here, we have all of these test scores. I would hope that this test was not out of 100, but let's hope that it was out of 50, and this person just got over a perfect score. Okay, so looking at this data, great, but it's not organized. And we know when we look at a set of data, we need to organize this from least to greatest right off the bat. So looking at these numbers, I see low 40s, great, oh, but I see 2 30 numbers. So 32 looks like the lowest, so I'm gonna write that out on my line. Then it's gonna go into 39. Then it looks like 42. Oh, 2 42s. Then we see 43, 46, 47 and 48. Oh, and I, of course, did not space out well. So 51 and 54 at the end. Oops. It's okay. All will be forgiven. So what I want to do first is count and make sure that I actually have as many numbers as I started with. I started with 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. So first steps. Handle your minimum and maximum immediately. That is the easiest way to get 2 steps out of the way. So my minimum is going to be 32 because that's the biggest number. Sorry, my minimum is 32 because it's the smallest number. And my maximum is going to be 54 because it is the largest number. So now I'm going to head into finding my median, which is my middle number. So I'm going to cross off values, starting with the lowest, highest, lowest, highest, until I get to the center. Boom. I'm at the center. However, I have 2 numbers left. And so what I need to do is find out what's in the true middle between those numbers. So we've practiced this a variety of different ways. I'm just going to add them together and divide by 2. So 43 plus 46 is going to take you to 89. And then we have to half that. So we've got to find out what half of 89 is. To find out what half of 89 is, we're going to divide that by 2. 2 can go into 8 perfectly 4 times. Now I'm going to bring down my 9. Can 2 go into 9? Totally. 2 can fit into 9 4 times. And we get 8. And we're left with 1. Can 2 go into 1? No. So at this point, I don't have any more numbers to drag down. So I'm going to add in a decimal point. And that gives me the ability to drag down a 0. Can 2 go into 10? Yes. 5 times perfectly. So I'm done with that division, and I have a median of 44.5. I am going to write that, in the center between these 2 numbers. And I'm also going to put that where I'm placing all of my values. So 44.5 is my median. And what do we do with our median? We always take it and drag a line straight through it. Now what we need to do is find the middle of the values that we're left with. So looking at this, I'm going to find my lower quartile and my upper quartile. My lower quartile is here. I'm going to start crossing off. And I'm left with 42. 42 is going to be my median of my lower half of data. So that is going to be referred to as my lower quartile. So I have 42 there. And then I'm going to do the same thing on this half of the data. I'm going to cross through 46, then 54, 47, then 51, and 48 is going to be my upper quartile. I have found all the different measures from my data set, but we still have one more value that's missing here, and that's the IQR. If you remember, we just went over what IQR is. IQR is the difference between the 3rd quartile and the 1st quartile. And we have those values here. What is the difference between 48 and 42? Well, that's 6. So the IQR is going to be 6. At this point in time, I'm now going to start my box plot graph. And so looking at this, my lowest number was 32. My highest number was 54. That's definitely a lot of ground to cover. So I'm going to think about a scale that I can use here. And I think I'm just going to count by 2s. Starting with 32, 34, 36, so I didn't quite make it. I was just 1 short, but that's perfectly fine. 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52, and 54. I just added that on there. And so now I'm going to start filling in my values that I found. My minimum was at 32. I'm going to start with that, place a dot there. My maximum was at 54, so I'm going to place a dot over there. Now I need to start with my median, 44.5. So 44.5 is not going to be exactly in the middle between 44 and 46, because exactly in the middle between those numbers would be at 45. So I'm going to place 45 marker there, and I know 44.5 is going to be halfway between 44 and 45, and I'm going to draw a line there. Next, my lower quartile is at 42, so I'm going to mark that. My upper quartile is at 48, so I'm going to mark that there, and I'm going to connect my box, draw my lines out, and that is my box plot for this test score set of data. Okay, so looking at this here, we're going to answer some questions that are going to help us analyze this box plot a little bit. So this first question says, blank percent of my data is in between 42 and 48. So this is where those percent sections are going to really come into handy. So I need to figure out what percent of my data is between 42 and 48. So 42 is here, 48 is over here. We learned that splitting up our box plot into 4 different sections, each section accounted for 25%. So this section would have been 25%, this section, 25%, this section, 25%, and this section, 25%. To go from 42, which is here, to 48, we had to hop over 2 sections. 25% in this section, 25% in this section. This box contains 50% of your data. And I know you're looking at this, and we know that 25% is a fourth of a data set, so shouldn't all these pieces be the same size? Well, not necessarily. This means that 50% of our data, as far as test grades, were in this area, which means this is a very concentrated score region, because 50% of the class scored between a 42 and a 48. So that's where the majority of people scored. Now it looks here that this contains the same amount of people, but it's a much more widespread section, which means that we don't have as many people in such a concentrated area like they were here. Okay, we have much fewer test scores in the 32 to 42 region. And that can be proven by just looking back at our test scores. We have way fewer there than we did in the 42 to 48 zone. We had a lot of different scores between 42 and 48. And that's shown by just going back and looking at your original data. Okay, next. What is the range? So we know the range is always the biggest number minus the smallest number. So I can either do that by looking at my original set of data, this data here that's not ordered, or my box plot. Since we're all about box plots today, I'm just going to use my box plot. So looking at my box plot, my biggest number is 54. My smallest number is 32. And I'm going to go subtract those. So 54 minus 32 leaves me with 22. So my range is 22. Next, what percent is below 42? So I've got to find what percent of my data is below 42. Well, looking at that, only one section is there. What's one section worth? 25%. So 25% of my data is below 42. 42 is at your first quartile. This is just one section, 25%. Next, which quartile has the greatest spread? Well, when we find out how far something's spread out, it goes over the largest area. We have a nice clean box plot, so it's really easy to see this here. The biggest section is definitely this first section over here. These two are probably the smallest. This one is fairly spread out in comparison with our box, but this one is definitely the longest section because it covers the most scores. So which quartile has the greatest spread? I would say the quartile that's contained between 32 and 42. Okay, thank you so much for following along with our lesson today. Hopefully this gives you success on your endeavors with completing the assignments later. If you have any questions, please feel free to reach out to your teachers via the It's Learning Messenger or email. Also, feel free to reach us at office hours. Thank you so much. Have a great day.